In question 5, we're given another two-way table. An experiment can result in one or both of A and B with probability shown in the table. First thing I always do with these tables is I add things together. 0.32 and 0.46 gives me 0.78. 0.32 and 0.19 gives me 0.51. 0.46 and 0.03 gives me 0.49. And 0.19 and 0.03 gives me 0.22. Whether I add this way or this way, I should get 1. So I now have the full table with all the totals. When it asks me the probability of A, that's a column. I look at that column total, and it's 0.51. Again, if this had been a table that instead of having proportions had totals, I'd want to make sure I was dividing by the table total to get the proportion. B is a row. Probability of B is 0.78. When they ask for the probability of A intersect B, that's a single cell in the table. Where A and B meet, they meet here in the cell marked 0.32. Probability of A union B. If I want to do that from a table, what I really need to do is I need to add together A plus B minus their overlap. So A, 0.51 plus B, 0.78 minus their overlap, 0.32. A 0.51, B 0.78 minus 0.32. Okay. So if I do this out, 0.51 plus really 0.46 gives me 0.97. At first I was a little worried I was going to get something greater than 1. That's why I stopped there for a second to consider. Remember, all probabilities are strictly bounded by 0 and 1. So if you're ever getting anything for these answers that's larger than 1, or less than 0, something probably went wrong. That said, I can see that A complement and B complement only has probability 0.03. Really, A union B is everything besides this one cell, so that double checks and that makes me a little more sure of my answer. For E and F, what I'm going to need to do is look at what's being conditioned on, what comes after the given line. In this case, given B means we know we're isolating this row. So when I go to calculate this probability, it's going to be out of the row total 0.78. Where they overlap within that row is this 0.32. If I put into my calculator 0.32 divided by 0.78, that's how I get the answer of 0.41. Same idea for F, except the order's reversed. Now, instead of being conditioned on B, it's conditioned on A. So we're going to go to the column marked A, which is out of 0.51. We're going to look for the overlap, which is this 0.32. When I put in my calculator 0.32 divided by 0.51, that's how I get, in my calculator, 0.6274. I'm going to go to 2 decimal places, so I'm going to call it 0.63. As always, be careful and look for whatever direction Cengage gives you with rounding. Question 6 tells me that P of A is 0.1, P of B is 0.6. It also tells me that A and B are mutually exclusive. I need to remember that mutually exclusive means they cannot happen at the same time. If they cannot happen at the same time, then they have no intersection. That's why P of A intersect B is 0. For the second part of the question, P of A union B, we're really using the same formula we did for D above. We should be adding the probability of the first plus the probability of the second minus their overlap. The key distinction here is they have 0 overlap. So because we know they're mutually exclusive, we can just add 0.1 plus 0.6 and not have to subtract anything because all of these were independent of each other. There's not a chance that there's any event that occurs in both A and B. That's the idea of mutually exclusive. So we don't have to subtract something that would go into both. For that reason, we just end up with 0.7. Question 7 has us getting into discrete probability distributions now. It asks us to find mu, the mean, sigma squared, the variance, and sigma, the standard deviation. The instructions are a little tricky here. When it says round to 2 decimals, it only wants you to do that for sigma. It does not want you to round the variance as you go. So just be aware of that if you're not sure why you're getting marked wrong on the variance when you get the standard deviation correct. That said, when I go to find the mean, I need to use my formula that says x value times its probability, plus next x value times its probability, plus next x value times its probability, plus next x value times its probability, and keep going until I've gone through every possible x value that this distribution can take on. I want to put it into my calculator just like that with the parentheses. So 0.25 plus 1.05 plus 2.3 plus 3.05 plus 4.2 plus 5.15. When I add them all together, I get a mean of 2.35. That's the correct answer for mu, the mean of my table. When I now go to try and find sigma squared, I need to take each of these individual x values, subtract the mean that I just found of 2.35, square the result, and then multiply by its probability. I need to do this for each of the possible values. I would double check any of this that I was doing on the test, just because it's real easy to make one wrong keystroke, forget to square something, forget a plus somewhere, and for that to throw the whole calculation off. I know that this is tedious, especially with 6 entries like this, but this really is an important part of statistics, understanding how to calculate these standard deviations and variances. So continuing on, I have 4 minus 2.35 squared times 0.2, and I have 5 minus 2.35 squared times 0.15. I'm going to put this all in at once, so parentheses 0 minus 2.35 squared times 0.25 plus parentheses 1 minus 2.35 parentheses squared parentheses 0.05 and parentheses plus parentheses 2 minus 2.35 parentheses squared parentheses 0.3 and parentheses plus parentheses 3 minus 2.35 and parentheses squared parentheses 0.05 and parentheses plus parentheses 4 minus 2.35 and parentheses squared parentheses 0.2 and parentheses plus parentheses 5 minus 2.35 and parentheses squared parentheses 0.15. When I do all of that, I end up with a total of 3.1275. Again, I understand why people are rounding this to 2 decimals. It says rounded 2 decimals here, but I'm just warning you, the system wants you to leave it as this full answer for variance and only round it after you take the square root when you're doing standard deviation. So when I go to do standard deviation, I take this answer, put it under the root sign, 3.1275. When I do that in my calculator, I get 1.76847. This is the one that I do want to round, so it's approximately equal to 1.77.